Okay, so this time we're going to solve a couple more examples on limits. That says we have the following. Let me have my pen first here. So number 3, say you're asked to evaluate for the limit of the square root of x plus 1 minus 1 all over x as x approaches 0. So that should give us, this time if we take a look, if we directly substitute again 0 here, we'll have square root of 1 minus 1, that will give us 0 all over 0. So what do we do here? We can rewrite this as the limit of the square root of x plus 1, okay, all of minus 1 all over x as x approaches 0 times, we're going to multiply it by 1 in this form, that is square root of x plus 1 plus 1 all over square root of x plus 1 plus 1. Recall your special product formula. U minus v times u plus v is equal to u squared minus v squared. So from here, that should give us the limit now of square root of x plus 1 squared minus 1 squared all over x times the square root of x plus 1, okay, plus 1 as x approaches 0. Now notice that square root of x plus 1 squared is now equal to square root of x plus 1 squared is now equal to simply x plus 1. Then you have minus 1 squared, this is minus 1 all over x, you have times the square root of x plus 1 plus 1. But as x approaches 0. But this time, you have x plus 1 minus 1 should give you x. And then divided by x, so that will give us actually the limit of x all over x times square root of x plus 1. You have plus 1 as x approaches 0. Again, x is just approaching 0, so you can cancel this one out, this 2 here. So you will now have the limit of 1 over the square root of x plus 1, okay, plus 1 as x approaches 0. So that should be 1 over square root of 1, square root of x is 0 here, plus 1, that becomes equal to 1 over square root of 1 plus 1. This is equal to 1/2. So this is our answer, 1/2. We proceed to the next example. Let's say number 4. Here, let's have number 4. I'm going to remove this one first. Okay. Let's just have number 2 here. The point is here. Let's just have number 2 here. Number 2 will now be, this is number 4 already, right? It's number 4, continuation one. So for number 4, let us have the following. That is, we take the limit of x cubed plus 1 all over x plus 1 as x approaches negative 1. Again, if we directly substitute negative 1, we will have 0 over 0. So you will have negative 1 plus 1 over negative 1 plus 1. So what do we do now is we try to factor x cubed plus 1. If you remember, our special product formula is actually for x cubed. Let us use another, say, another variable so that you will not be confused. Use, okay, erase that one. Erase that one. Let's use another variable there. So, if we make use of u cubed plus v cubed, that's actually equal to u plus v, okay, times u squared minus uv plus v squared. Okay, it's v squared. And if you have u cubed minus v cubed, that is factored as u minus v times u squared plus uv plus v squared. At this point, what we're going to make use of is the factor of u cubed plus v cubed. So, we can rewrite this now as the limit of x plus 1, okay, times x squared minus the product of this, x, 1 times x is x, plus 1. That's 1 squared, but 1 squared is 1. All over x plus 1. And again, notice, since x approaches negative 1, that would mean this one is not equal to 0. Okay, you can cancel that out and come up now with the limit of x squared minus x plus 1 as x approaches negative 1. But that should give us now equal to the value that's equal to negative 1 squared minus of minus 1 plus 1. But what is negative 1 squared? It's equal to 1, then minus 1, then plus 1. Meaning to say the limit now of x cubed plus 1 all over x plus 1 as x approaches negative 1 is equal to, what is this equal to? That's equal to 3. Okay, so we'll end up with the 2 examples.